Good evening, class, and welcome to our performance management class. Today, we are taking the topic learning an experience curve. We started this topic last time in the last class, and today we are going to look at it. We talked about the formula method, which is in the formula here is y equals to ax raised to power b, where b is the log of r all over the log of 2. So it means here that r must be expressed as a decimal. So if you have something like 80%, you need to change it to 0.8. Now, we said y is the cumulative average time per unit for all units made. That's talking about production. What it means here is that cumulative starts from the very first production you make. That means X is the number of units you made so far. And when we say X is 10, it means that from unit 1 down to unit 10, that is what we call X. Then Y is the cumulative average time. And I could also say average costs. So we can use either average time or average costs. Cumulative average time or average cost for all is the time. When you see time here, you can also use costs. So is the time or cost for the first unit, where B is the learning factor. Let's look at the keys, the steps to solving linear learning curve problems. First of all, you need to observe the unit of measure of A. So you have to check if A is stated either in units or in batches. That is important. Anyhow it is being stated, that is how your answer would be. So the unit of measure of A will dictate how the answer will be, whether it will be in batches or in units. The second step is to check the value of measure of A, either in hours, that is talking about time, or naira, or we can even say dollars. For those joining outside Nigeria, this could mean the costs. Then we check the value of B. If B is not given, we'll need to find B by using log r over log 2. But if B is given, then it's fine. Sometimes you'll be asked to find the R, which is the learning rate. You have to make R subject of your formula. Then we need to find the value of Y. That means the Y in the question. You have to get the value of Y after getting the value of A and the value of B, and you know the value of R if B is not given. Most times, X is given. But in some rare occasions, X may not be given. So that way you just put all the things together, all your ingredients together to get Y. And I said that Y is the average value. We said it's a cumulative average value. That means normally when we want to look for average, we first get the total. After getting the total, we divide by the number of observations to get average. But here you are not given the total, we are given a formula to get average without going through the stress of getting total. After getting the average, we need to now find that total by multiplying x with y. That's step 5. Then if we are looking for incremental value, you repeat steps 5 and 6. Then you look for the incremental value t by using this equation. We'll get to that. Then use this value of t to multiply the number of units of batches to get the remaining value of t after the steady state. Then you need to find the total labor hours or labor costs depending on the value of A given in step 2. So we are going to be looking at these steps as we solve a question. So I'm going to create another instance of this worksheet here so that we can always scroll and come back to it. All right, so this is it. Now let's go down to see a question. I will keep this as a come back here now. Let's go to the question. Daily Company Limited has developed a new product. Details are as follows. Before we go further, I will have you know that this is an ICANN past question paper. So this is an ICANN past question. We are told that selling price and product life cycle. So this is combining two topics, product life cycle and learning curve. The product will have a life cycle of 10,000 units. What it means is that this could be a component. And when I use a component, I usually want to make use of a small component, let's say battery. Battery in a wristwatch or in a calculator is a component. Let's say for a particular new type of calculator, they are going to make 10,000 batteries overall for the period. So that's what they mean a life cycle. So for that brand, 10,000 units of that component to be produced. It is estimated that the first 9,000 units, that means when X is from 1 unit up to 9,000 units, that's what they mean by the first 9,000 units, will be sold for 3,100. So this is the selling price for each of the products. This is the product here. Then the product will enter the decline stage of its life cycle. So now, this is not even talking about component. This is talking about a product itself. Now let's say the battery we use as an example is a product. It can be used in calculators, it can be used in watches and all that. But this is a brand, and they are only going to make 10,000 units of it. And the first 9,000 will be sold for 3,001. So in product life cycle, there are at least 4 stages. There is the introduction stage, there is the growth stage, there is the maturity stage, and the decline stage. So the decline stage is after the first 9,000. Now they said it is difficult to forecast the selling price for the 1,000 units that will be in that decline stage, that will be sold in that stage. So if it is difficult to forecast, so it is possible that we are going to be asked to forecast the selling price. So let's keep our fingers crossed. Now we are told about costs. Now this is where you should pay attention. Costs, labor. Now, learning curve, before I go further on this question, has to do with labor. Learning curve has to do with manual labor. Why? Because as human beings, we learn when we are doing work repeatedly. Even it's a machine has been programmed to do that repetitive work and it doesn't learn. Machine goes as a particular efficiency. It doesn't increase its learning rate or reduces its learning rate. But humans, as they keep doing it, they become more proficient. They reduce their learning time or their execution time and they increase their learning rate. Now, learning, for a learning to take place, it means that there must be human activity. Also, it must be a bit difficult. That means you have to learn, but not too difficult because you have to get to a stage where you have learned to the limits. So you have to learn, but it is going to be difficult a bit. Now, when you learn, you expected that when you've reached your steady state, that steady state can be used for future planning. So it means that if you are now doing job, when you see labor rates or you see labor time taken for a particular job to be done, it is because they have learned up to a particular point that they can predict. And that also means that there will be minimal labor turnover. This means that you will spend money, time, energy, effort to learn with your workforce. Now, when your workforce finish learning on the job, you have to keep them so that production can be planned, can forecast. But if there's a high turnover of labor, people learn and leave, learn and go, people will be coming newly to start learning again. And so learning will keep on going. But we don't want learning to be forever. We want learning to stop at a particular time because the staff that is being used have learned over time and they are permanent. Let's go to this question. Labor will be paid at 300 naira per hour. Now, what is it telling me? Labor is given to us at value in naira, not in hours. So you are seeing here, I am thinking that my answers is going to be in naira. Let's keep our fingers crossed. Other variable cost here, we are told that it will be 950 naira per unit. Fixed cost, we are told that fixed cost over the life cycle. So for the whole 10,000 units, fixed costs will remain. Somebody is asking me what ICANN diet question is this. I can't say offhand, but we will look at it and we will get it. Fixed cost over the product will be 2 million naira. 2 million naira. So for the whole 10,000 units, which is the whole product life cycle, this is going to be 2 million naira fixed cost. And we are now told that labor rates and other costs will not change, throughout the product life cycle. So it means that labor rates will still be 300 naira per hour for the whole of the 10,000 units. Variable overhead cost will be 950 naira per unit throughout the whole 10,000 units. Now let's go to learning curve and let's start observing our rules. Now, now look at the thing here. Hold on a minute. This is becoming interesting. I'll hold this now. Now let's go to the rules again. Observe if the unit of measure of A is in units or in batches. So anywhere you see the word first, The next thing that comes after the word first is the unit of measure. Anything after the word first is the unit of measure. So let's look at this question again. The first batch. So our unit of measure is batch. Now they say the first batch of 100 units. So a batch is like a crate. Now this crate is taking 100 units per crate or per batch. So we've seen A. I will now write it down here. This is A is in batches. Batch. All right. Then they said there will be an 85% learning curve. So what it means here, oh, sorry, I'm getting ahead of myself. The first batch of 100 units will take 1,500 hours. We'll go back to the next step. The value of B is either going to, sorry, the value of measure of A is either going to be in hours or in naira. So it means here that this is going to be in hours. So this is in hours. So we are looking at hours. This is batch per hour. Batch per hour. One batch is taking us 1,500 hours to make. There is going to be a 85% learning curve. So we start converting this now. We say R is equal to 0.85. That's our learning rate. That will continue until, the word until tells us that this is when learning stops. So I'll say until 6,400 units have been produced. Now we will say learning stops at 6,400 units. But wait a minute, A is given to us in batches. So we need to convert this thing to batch. All we simply do is to divide 6,400 units, divide them by 100 units, it gives us 64 batches. 64th batch. Now we are told that trying to confuse you here with units and batches. So once it's recognized that it's going to be batch, if they give you units, please convert to batch. Now notice here, any batch produced, they didn't say any units produced, but they told us it's going to stop at 6,400 units. They should have just said 64th batch. Now, any batch produced at this level will take the same amount as the 64th batch. So we are going to be interested in the 64th batch. And there is a way we will get that 64th batch. The batch size is constant at 100 units. So that means one batch equals to 100 units. 6,400 units is going to be 6,400 units divided by 100, giving 64 batches. That's fine. Required. Calculate the cumulative average. The cumulative average time. Now, why am I saying it's time? Because your A is given to you in hours. So they are going to ask you for time. And this cumulative average is telling you to find Y for the first 64 batches. So you see here, first 64 batches. That is cumulative. Your X will always be cumulative. And what is X? X is the number of batches. So X here, we are told that X is 64. So let's do that now. Let's do that now. So this is so let's start now. This is example 1. Sorry, I'm supposed to use this. Example 1. Example 1. And this is an ICANN past question. I will get the question number. I will put it later. Okay, so what's the name of the company? The company is Daily Company Limited. So let's say Daily Company Limited. Daily Company Limited. All right, so we are heading somewhere. Now, we are told here, what are we looking for? We are looking for Y when X is 64. So the A is to find the cumulative average time for the first 64 batches. Okay, so here we go. What are we given? We are given, okay, so this is the formula here. Y is equal to AX raised to power B. We were given B as 85%, which we converted to 0.85. We were also given A as 1,500 hours. So that's it. Now, our X is going to be 64. So this is like first 64 batches. So which is like, I can call it here. This, look at the way I usually like to make it, X1 to 64. So this is like X1 to 64. So it means from batch 1 down to batch 64. That is what this is. So we are asked to look for Y. So our Y is unknown. So we can come here and say Y, but hold on a minute. Now, they said learning rate for an index of 85 is 0.02 minus 0.2345. So if you just look at this formula here, B is already been given. Okay, B is not given. Sorry, B was not given. I beg your pardon. It's R that was given. So your R is given here. We need to find B. But we are giving B, but we need to test. Let's test it in case we are not giving B, to know how to look for it. It's going to give me log R divided by log 2. So which means it's going to give me log 0.85 divided by log 2. This is still going to give me, what is log of? Somebody is asking the question. Somebody is saying it's question 7 of May 2015 diet. So let's just put it there. Question 7, May 2015 diet. Thank you for that. So let's say question 7, May 2015. Let me say question 7, May 2015. All right. So let's come now. What is your log of 0.85? Let's get it now. We're going to change our calculator. Let's see if we can change our calculator from standard to a scientific calculator. Let's see. Yes, I have a scientific calculator here. So I will say log. Okay, we don't start with log. So some calculators does not start with log. So we say 0.85. Then you press your log. See what it gives us? 0, we'll take it to 4 decimal places. 0 point minus 0.0705 0706. So I will say minus 0.0706. Now divided by, I'm going to bring another calculator. Let me bring another calculator so that it's going to be okay. So I'll need to stop and start sharing again. I have to start sharing so that this second calculator will show. All right. I believe we can now see my screen. Use it to calculate log 2. So we have 2 and we'll press log. I know log 2 is 0.3010. Let's see. Yeah, 0.3010. So I'll come here, 0.3010. So I'll go back now to this one. Okay, I'll need to copy everything here. I'll need to copy everything here and use it in the first one. Let me copy. I'll go to the first calculator, and this is a numerator. I will divide it by the denominator. This is the denominator. I've divided it by the denominator, and it gives me this minus 2345. So it gives me minus 0.2345, which is equals to minus 0.2345. So you see here, this minus 0.2345 is the same thing that we are told here, minus 0.2345. So we don't need to do this. But in case you are not given, this is how you get it. Now we've gotten our B to be this value. So we'll now y is equal to ax raised to power b. Now what's our a? Our a is 1500. We'll now say multiplied by, open a bracket, your b, your x is what? 64. Then it will be raised to power minus 0.2345. We will always be using it in 4 decimal places. So now this is going to be 1500 multiplied by, now let's carry out this calculation. Bring our calculator now, clear this one off, and we say 64, your power raised to power. You go to where we have x raised to power y. Of course, you see 64 is x. Now we are saying raised to power what? So this is it. This other sign is also raised to power. So if in case your calculator has this sign, it's fine. If it has this sign, it's the same thing. Raised to power. Now, don't just go and put minus this whole thing. You're going to get a different answer. Just put 0.2345. Then you come and put this minus before it. That serves. So this is 64 raised to minus 0.2345. When I press the equal to sign, it gives me this. It gives me 0.377110. Because if I want to approximate that 9 to 10, it's going to give me 1. 0.37710 to 4 decimal places. 0.3771. 1, 2, 3, 4. All right. Now, when you multiply this by 1500, let me leave the thing in my calculator like this. I'll just multiply this by 1500. I will give my answer 65.6565.64. So what it means here that this is the hours per batch. So this is the answer. What is batch for the first 64 batches? And we just found out that for the first 64 batches, we are going to be doing an average of 565.65. What it means is that for the first batch, you spend a whooping 1,500 hours to do one batch. By the time you did the second batch, the time taken per batch reduces. When you go to the third batch, the time taken to do batch 1 and batch 2 together and batch 3 together, if you find the average, it has reduced. When you get to the fourth batch, the efficiency improves. And when you get the total batch time, the total time for the batch divided by the number of batch, you find out that the time reduces per batch. That is how you will be doing it until you get to 64 batches. So as you are going, each time you are going, your time per batch is reducing. So it shows you that you are learning. So this is your answer. Now, the time taken for the 64th batch. The time taken for the 64th batch. What does this mean? What does this mean? Now, this is what I mean. Go to the second one. The second part of the question, which is B. Time taken for the 64th batch. So this is small t. Okay, so you find out that there's a difference between the time taken, the average time taken for 64 batches, or the total time taken for 64 batches. Okay, now let's give this analogy. Let's say I come to PM class and I say, what is the average age of the 3 students in the class? The average age of the 3 students in the class. We'll look for the average age. If I tell you what is the total age of the 3 students in the class, all we need to do is have their total, the age of the first person plus the age of the second person plus the age of the third person. If I ask you to find the average age of the 3 people, you need to look for the total of the 3 and divide by 3. What if I tell you, give me the age of the third person in this class? So it means that the third person that came into the class, we need to find his age. That is what this thing is doing here. And that means here that before you get to 64th, you need to, you can get 64th. So how do you do that? So look at what this thing is asking us to do. This time, which is small t, I'll make it small t, and I'll put something here, 64. This shows that this is the time taken for the 64th batch is equal to the time taken for the first 64 batches, which is big T, minus the time taken for the first 63 batches. Because I said when you are measuring this learning curve stuff, you start from the origin. It's just like putting your tape and you start from 0 and you measure size 64. And they said, okay, you want to know only 64. You cannot just come and say, okay, come from 63 to 64. Yes, that's it. But you need to first of all measure the whole of 64 and mark it. Then come again and measure from 1 to 63 and mark it. The difference between the two markings is the time taken for you to move from 63rd floor to the 64th floor. Just like somebody with 64 years and he has to climb from 63rd year to the 64th year. So that's what we are going to do. This is the guiding formula. But we don't know t. We are told that t is equal to x multiplied by y. So which y do we know? We already know y. So I would like to call this one here. Let me say this is, I can call this one y 64. I would like to call it that way. So we already know y 64. So we can say t 64, or which I can say 1 to 64, any of them, is equal to, when x is 64. When x is 64, so this is going to be 64 multiplied by when y is 64. That is going to be 545.63. Is that what we got here? 565.64. Sorry. 565.64. So now here is it. We'll now get our calculator. I can decide to multiply it here straight times 64. And that will give me, I'll make it in whole number. That will give me 32. Didn't get it clearly that first time. 36201. 36201. 36201. 36201 hours. So this is the time taken for the whole of 64 batches. Okay? Now, we need to look at the time taken for the whole of 63 batches. So how do we do that? It means that we need to look for the value of y when x is 63. So you come down here, you will now look for y 63. And that will give me a, and I'll say x 63. If I want to, I don't need to put as x 63. It's still the same, ax raised to power b. And our a happens to come constant, 15. Our x now is 63. Now instead of 64, we are using 63. Okay? Then raised to power minus 0.2345. I think that's what we use, 2345. All right. So here we go. Our calculator activated. We'll start with the we'll start with 63 raised to power, I will say 0.2345 5, and I'll put this minus here. This is this. All right. So that's going to give me 0.37. I will just multiply it straight by okay, let me just put this for the sake of this question. 0.3785. 0.378515. So when we multiply it by 15, we multiply it by 1,500. 567.74. 567.74. So this is 567.74 hours per batch. So you've done that of y. Y63 gives you this. The next thing to do is to look for T63. T63 is equal to x times y 63. Now your x is already 63 and your y 63 is 567.74. We have it in our calculator. Let's multiply it by 63 and we'll put our answer in whole number times 63. It gives me 35,767. 35,767. 35,767 hours. All right. Now that we've done that, it's time to do this. So we'll say T64 is equal to big T 64 minus big T 63. Now, take note that here is 1 to 64. And take note that here is 1 to 63. And this is just 64th. So what do we have? 1 to 64 gives us 36201. We have 36201 minus 35,767. All right, so we'll have our calculator activated now. We'll say, I'll need to clear this. I don't want to read this. 767. That gives me 434 4 hours. So you say the time for the 64th batch is 434 hours. Now, that's the answer to the second part of the question. But if you look at it here, there's something we were told. They said any batch produced after this level, after the 64th batch, will take the same amount as the 64th batch. How many batches were we producing? We produced 100,000, 10,000. So we'll come back to it. We'll go to C, the average selling price of the final 1,000 units. So you see, I told us that it was difficult to forecast the selling price for the 1,000 units. And now they are asking us to find the average selling price of the 1,000 units that will allow Daily Limited to earn a total profit of 2,500, 2,500,000 from this product. Okay, so we're going to be looking at it here. The C part, average selling price for final 1,000 units. So that's it. So we'll now say total units produced, which is ten thousand units. Let me put units here. Total, because we know our value, our unit to convert this to batch is going to be 10,000 divided by 100 units per batch. That will give me 100 batches. Okay, all right. Then we say learning stops at batch or batch 65. Use the okay. So sorry, network. So we said learning ends at batch 64. Therefore, for batch 65 to batch 100, we use the same as per batch, which is per batch. 434, 434 hours per batch. Need to confirm things before, right? 434 hours per batch. So what it tells me now, so we'll say is equal to, we'll say T 64, which I will say 1 to 64 plus, now this is just my own concept, I will say T, I will come here 65 to 100. So you have to get the first 64 batches time plus the time for the 65 to 60 to 100 batch. By the way, how many batches are here? So from 65 to 60 to 100 is 36 batches. So I will come here and say T1 to 64 has been gotten before. 3620201. So we'll write it 36201. Now plus, they say any batch produced after the 64th batch, which we say is 434 hours per batch, multiplied by the remaining 36 batches. So this will give us 36201 plus, let's do our calculation here, 434, that gives us 15, 624, 15, 624, 15, 624. Now let's add them all together. 36,201, 51,825. Now come here. Hours. This is my total labor rate. Our labor rates, labor we paid at 300 naira per hour. They say the labor rates will not change. 100 naira per hour multiplied by 51,825 hours. That will give me how many naira or dollars? Anyone? I'll multiply this by, what did I do? I'll multiply this by, if you can see my calculator, I can't even see my calculator. Let me stop sharing and share again. All right, I can now see my calculator. So I will say 51,825, 51,825 multiplied by 300. Now that gives me 15,547,500. 15,547,500. 15,547,500. Now this is our labor cost. So you need to remember this when we are looking for selling price. So what do we do? We know that revenue revenue is equal to what? Quantity times price. I put naira as the price. Okay? We can now divide these two into the first 9,000 units plus final 1,000 units. Okay? Now I want us to note this. We'll come to this, but let's build up to this point. Because we are asked to find selling price that will allow us to make a profit of, we are told that the selling price should allow us to make a profit of 2,500,000. So let's start with that profit. What did I do? All right, so let's start with the profit and work our way from profit down to selling price. So we know that contribution, sorry, let's move like this. Revenue minus variable costs will give us contribution, right? And when we minus contribution, when we say contribution minus your fixed costs, will give us our profits. So this is it. You have your revenue, you remove fixed costs. From what we've learned, it will give you contribution. When we remove fixed costs from contribution, it gives our profits. So if we have to start from profit, it means profit. If this one comes to this side, this fixed cost is carrying a minus. If it moves to this side, it becomes plus. Profit plus fixed cost should give us contribution. We have our profit, our target profit to be 2,500,000. What's our fixed cost? We'll go to the question to look for the fixed cost. Our fixed cost here is 2 million. So we'll add 2 million to that. 2 million. So when we add it here, we have 4,500,000, which is our contribution. Revenue minus variable costs will give us contribution, isn't it? Now, if this variable cost moves to this side, it will become contribution plus variable cost will give us revenue. So let's address that. We already know our contribution. Our contribution is 4,500,000. Now, what's our variable costs? Our variable costs, we are told, variable costs comprises of labor. There's no material here, but they said labor and other variable costs. So that means material could be also inclusive in the other variable costs. So they just divided variable costs into two. labor and others. So labor has been given its own other variable costs. So let's start with that other variable costs. Other variable costs will not be multiplied by in units. If you want to make it per batch, all you need to do is just divide by, no, you just multiply by 100,000, by 100. You multiply by 100 to get per batch. But let's leave it here. It is per unit multiplied by 10,000 units. So this is for just other variable costs. Now plus what we've done for labor. What we did for labor, 15,547,500. 15,547,500. So this is 15,547,500. So this will now give us 4,500,000 plus this bracket is still here. 950 multiplied. Why is this screen blocking me? Something is blocking my screen. 950 multiplied by 10,000. That gives me 9,500,000. So I will come here, 9,500,000 plus 15,547,500. So let's just add everything together because this is a plus in everything. 15,547,500, and I add 9,500,000 to it. Then I add 4,500,000 to it. 29,547,500. So 29,547,500. This is our revenue. But that's not revenue. We're not asked to find revenue, right? We know that revenue is equal to quantity times selling price. So what we're going to do now is we are going to do it in two phases. Quantity for 9,000 times the selling price for 9,000 plus the quantity for 1,000 times the selling price of 1,000. Now, this is the selling price that we are asked to do. Of course, our revenue here is 29,547,500. Now, it's now equal to quantity here is 9,000 multiplied by, we are told that each of them is being sold for 3,100. So the first 9,000 units is sold for 3,100. So you come here, this is 3,100. Now let's leave this side as, now this is quantity is what? 1,000 multiplied by SP. So this is the selling price we are looking for. This happens to be 29,547,500. Now 9,000,000 or 9,000 multiplied by, so let's do it, 9,000 multiplied by 3,100. That gives me 27,900,000. 27,900,000. Now say plus 1,000 times SP will give us 1,000 SP. So let this unknown be in one side. So this will now give us 29,547,500. Now this is having a plus sign. If it moves to this side, it becomes a minus. Minus 27,900 will now become equal to 1,000 SP. So we are going somewhere. We will now less this. I have this in my calculator here. I will just put a minus sign to read it, and I will remove it from 29,547,500. That will give me 1,647,500. 1,647,500. 1,647,500, which is equal to 1,000 SP. Therefore, SP will give me 1,647,500 all over 1,000. So let's bring the calculator now and divide this by 1,000. That will give me 1,647.5. So it's going to give me 1,647.5, or I can say 0.50. Someone can say 1,648. Anyone you do, you are correct. So that shows you here that you have used your learning curve to get all of this together. So you see here, remember the way we did it, although there's a solution here which you will still look at. But remember the way we did it. We started with our value or our unit of measure for A, and we said the first batch. So batch became our answer. Batch became our answer. So all the times we have been getting our hours, we used to say hours per batch, not per unit. So we know the measure of value, measure of A is in batch. That's the unit of measure. Then the value is in hours. So we usually say hours per batch. Hours per batch. We look for our B. We found B, right? Because R was given. R was given, and we use it to look for B. But in this question, we are not supposed to even look for B because our B was given us here. Then we now look for the first 64 batches. It is always, even if we are not giving, always look for the first number of hours that always look for the cumulative from the beginning to end. So the beginning of your learning, so in this case, learning 3 batches, although in this case to look for the 64th batch. It that from the 64 batches and we look for the first 64 and we got our 6 because anything follow the steady state when you are also solving it or not. It's a good practice. Due to want to stop for now. 2 more questions on learning curve. Questions on learning curve. So let me prepare your mind for those questions we are going to solve. The moment you see my screen, I need to look for the moment you see my screen. Okay, so let's share my screen so that you see the questions you are going to be solving next time. Someone said we did May 2015 question number. What did he say we did? He said we did May 2015 question 7. So if that's the case, May 2015 question 7. I don't think, because I can't see question 7 here as. Okay, so let me identify all the question that has learning curve. Okay, so this is one of them here. Let me name this one. Let me call this A9. Let me call this one A9. This is one of the questions we are going to. This is life cycle costing and learning curve. We'll check it. This is another one here. Okay, this product life cycle. Okay, this another one here. I'll call this one A9. So these are 2. I'll need to check this at May 2018 and May 2016. Oh, it's 2016 the person meant, not 2015. 2016. The person wrote 2015. May 2016. So let's confirm. May 2016, question number 7. I need to confirm that. May 2016, question number 7. Good. This is the question we just solved. This is the question we just solved. All right. So in the next class, we have to solve 2 more questions. And we are saying we are going to, that means we just solved this. So let me ensure that we colored this one to show that this has been solved. In the next class, we are going to solve this. So let's look at how the question is. November 2018, you'll be seeing the kind of question we'll be solving. November 2018. Question number 4. So let's see question number 4. All right. So this is the kind of question we'll be solving. And look at product life cycle and all that. We are going to be solving this question and solving one more question. Then we'll call it a day on the learning curve problems. So thank you so much for coming to class. It was quite an experience, a learning experience. See you in the next class when our learning experience will go to another dimension. We'll be solving November 2018, question number 4. So if you like, practice and try to learn this question, because there's a way I am going to solve it that looks simpler than the solution that is presented in your study pack. So thank you so much, and we'll see you again in the next class.